EMT, or electrical metallic tubing. Set screw connectors are often preferred over compression connectors when dealing with fault currents. This preference stems from several key factors related to conductivity, heat dissipation, mechanical strength, and grounding. Firstly, set screw connectors typically offer better conductivity. This is primarily due to their design, which provides a larger surface area of contact between the EMT conduit and the fitting itself. A larger contact area translates to a more robust electrical connection, effectively reducing resistance and facilitating a smoother, more efficient flow of current. In contrast, compression connectors, while suitable for many applications, may not offer the same extensive contact area, potentially leading to higher resistance at the connection point. Secondly, set screw connectors are better at heat dissipation. During a fault event, a significant amount of heat can be generated due to the sudden surge of current. The larger contact area inherent in set screw connectors aids in dissipating this heat more effectively. This helps prevent the connector from overheating, which is a critical consideration, as excessive heat can lead to the vaporization of the connector's gland or other components, compromising the integrity of the electrical system. Compression connectors, with their potentially smaller contact area, may not dissipate heat as efficiently, increasing the risk of overheating under high fault current conditions. Thirdly, set screw connectors provide enhanced mechanical strength. They are generally more resistant to pull-out forces compared to compression connectors. This is particularly important in scenarios involving high fault currents, where the sudden surge of energy can exert substantial mechanical stress on the connection. A mechanically stronger connector is less likely to fail or become dislodged under such stress, maintaining the integrity of the grounding path and preventing potential hazards. Fourthly, set screw connectors offer an improved grounding path, especially when used in conjunction with an insulated grounding conductor. The larger surface area contact between the set screw connector and the EMT conduit contributes to a more effective grounding path. This ensures that fault currents are safely and quickly directed to ground, minimizing the risk of electrical shocks and equipment damage. The set screw design firmly bites into the conduit, providing this crucial connection. Moreover, set screw connectors are designed specifically for use with the EMT conduit and are engineered to comply with relevant electrical codes and standards, such as the National Electrical Code, or NEC. The NEC outlines specific requirements for electrical installations, including the types of connectors that are suitable for use in different applications. Adhering to these codes is essential for ensuring the safety and reliability of electrical systems. While compression connectors can be suitable for certain applications, set screw connectors are generally considered the superior choice for carrying high fault currents and providing a reliable, code-compliant connection. It is important to consult the NEC and local electrical codes to ensure that the appropriate type of connector is selected for a given application. The choice between set screw and compression connectors should be based on a careful assessment of the specific electrical requirements, including the anticipated fault current levels, the environmental conditions, and the applicable codes and standards. Correct installation is crucial for either type of connector to function effectively. Proper torquing of the set screws on set screw connectors is essential to ensure a secure and reliable electrical connection. Similarly, compression connectors must be properly tightened to achieve the correct level of compression and maintain a good electrical bond. In summary, while both set screw and compression connectors have their place in electrical installations, EMT set screw connectors offer distinct advantages in situations where high fault currents are a concern. Their superior conductivity, heat dissipation, mechanical strength, and grounding capabilities make them a preferred choice for ensuring the safety and reliability of electrical systems. Remember to always consult with a qualified electrician or electrical engineer to determine the most appropriate type of connector for a specific application and to ensure that all electrical work is performed in accordance with applicable codes and standards. It is also important to note that the effectiveness of any connector, regardless of type, depends on proper installation techniques. This includes ensuring that the conduit is properly prepared, that the connector is correctly aligned, and that all screws or fittings are tightened to the manufacturer's specifications. Failure to follow proper installation procedures can compromise the integrity of the connection and reduce its ability to safely carry fault currents. Regular inspection and maintenance of electrical connections are also essential for ensuring their continued reliability. This includes checking for signs of corrosion, damage, or loose connections. Any problem should be addressed promptly to prevent potential hazards. Furthermore, understanding the specific application and the anticipated fault current levels is crucial for selecting the appropriate connector. In situations where high fault currents are expected, it is generally advisable to use set screw connectors, as they are specifically designed to handle these conditions. However, in other applications where fault currents are less of a concern, compression connectors may be a suitable and cost-effective alternative. Consider the environment in which the connectors will be used. In corrosive environments, it is important to select connectors that are made from corrosion-resistant materials. This will help to prevent the formation of rust or other corrosion products, which can degrade the electrical connection and reduce its ability to carry fault currents. The National Electrical Code, specifically Articles 250.8 and 314.4, addresses the requirements for grounding and bonding electrical systems. These articles provide guidance on the proper methods for connecting grounding conductors and equipment grounding conductors to enclosures and other metal parts of the electrical system. It is important to follow these requirements to ensure that the grounding system is effective in providing a low impedance path for fault currents. For example, NEC Section 250.8 states that grounding conductors and bonding jumpers shall be connected by exothermic welding, listed pressure connectors, listed clamps, or other listed means. This section emphasizes the importance of using listed and approved connectors for grounding and bonding applications. NEC Section 314.4 requires that metal boxes and conduit bodies be grounded in accordance with Article 250. This section ensures that metal enclosures are properly grounded to provide a safe path for fault current. The type of connector used to connect the grounding conductor to the metal enclosure must be listed for the purpose and must be properly installed. Grounding and bonding are essential for electrical safety, and it is crucial to follow the requirements of the NEC to ensure that the grounding system is effective in protecting people and equipment from electrical hazards. When dealing with electrical systems, safety should always be the top priority. Working with electricity can be dangerous, and it is important to take all necessary precautions to protect yourself and others from electrical hazards. Always de-energize electrical circuits before working on them. Use appropriate personal protective equipment, such as insulated gloves and safety glasses. Follow all applicable codes and standards. If you are not qualified to perform electrical work, hire a licensed electrician. In summary, set screw connectors generally offer superior performance in high fault current situations due to their enhanced conductivity, heat dissipation, mechanical strength, and grounding capabilities. However, the selection of the appropriate connector should always be based on a careful assessment of the specific electrical requirements, the environmental conditions, and the applicable codes and standards. And remember, proper installation techniques and regular maintenance are essential for ensuring the continued reliability and safety of electrical connections.